Good morning, everybody. Eric Knight here with Watershape University. I am in a customer's backyard, and there's some lessons to be learned from this pool. I'm going to show it to you when I turn the camera around, and you might recognize this barrel. Throw back to the old days, but we're not doing a startup. We're actually going to be lowering the alkalinity because that barrel now has a ball valve on the bottom of it, which makes it a much faster addition of acid. We have to get about a gallon of acid in here, and instead of breaking our backs putting bucket after bucket and buckets of water to dilute a gallon, I could just do it all at once and then we'll brush it. But essentially, there's two things going on with this plaster. We're talking with the customer using dry acid. For those of you who use dry acid from retail stores, they are sodium bisulfate, and they put a lot of sulfates in the water. And when you have a lot of sulfates in the water, that sulfate actually starts to attack the cement. A lot of people don't realize this. We use muriatic acid when we dilute it. Muriatic acid itself in concentration is pretty harsh. Let me get in the shade. But when using dry acid, it may seem less harsh, but you're going to see, I'm going to show you up close, there's actually some issues that can happen. So this plaster, when was this plastered? April, so a few months. So it's not an old surface. The pool is old, but we're looking at the surface here. So let me turn this around. We just did an experiment, actually, because there were some flakes. It's a saltwater pool. And then I had a little bit of water with some diluted muriatic, and I took one of the flakes that we picked up, and sure enough, it dissolved, which proves it was indeed calcium carbonate. But this is supposed to be a black pool. And you can see right here, oh, let's get rid of the glare. All right, notice that all the white is around the pebbles, not on them. This is not scale. Scale, as you may remember, is an oversaturation of calcium carbonate that has to fall out of solution. Oh, hold on. Can we turn the hose off? So scale is an oversaturation, meaning a high LSI. So it would land on top of pebbles. It would land on top of aggregates, but that's not what's happening here. What's happening is an aggressive LSI, which means the water has a red LSI on the Orenda app, and it's pulling calcium out of the surface. And we know that because it's not on top of the aggregate, it's between them. But there's something else going on too, and I'm gonna zoom in. I think this will be a good angle for it. Let me see. We know, I'm gonna have to get this water nice and calm. I hope it shows up. I can post photos of it too. But if you look really carefully, let's see if I can get in the better angle. There's it almost looks like granules of salt on top of pebbles and everything. Let me get in the shade. I think we'll get a better angle. Here we go. Oh, I touched the water, sorry. I don't know if you can see this, but on top of this surface, there's like little granules of salt, but they're not salt. Something tells me that it's actually calcium sulfate scale. And the reason I say that is because if it was calcium carbonate, if it was like calcite crystals, it wouldn't be on top of the pebbles. It wouldn't be on top of the plastic fittings or the tile. And yet it is, which means it's coming from the water, landing on the surface. Think logically about this. It has to be coming from the water if it's on top of something that's non-cement based. What could that be? It's not salt. The only other thing I can think of that looks exactly like this is calcium sulfate. The reason why is this is using, it's using a lot of acid, but it's using too much of it. And it's using sodium bisulfate. So the sulfates are climbing through the roof. There's plenty of calcium. They're also using cal hypo to supplement the salt system. It's a perfect storm to get calcium sulfate. Now this pool was just redone in April, so it doesn't take a long time and you don't have to be in the desert. So Jeff, if you don't mind, let's open that ball valve. So right now we've got a half gallon of acid in the Orenda barrel. We put just wide open. And we've diluted it with a full 55 gallons. This is much faster than using bucket after bucket after bucket. And then we're gonna brush, and we're gonna get the alkalinity down. Now again, the reason we're getting the alkalinity down is because the alkalinity is too high and it's creating flakes in the saltwater pool. That's because the pH ceiling is about 8.31, I think, based on my calculator. So 8.31, pretty much guaranteed. The pH right now is higher than the Taylor kit can read, which means it's probably about 8.31. So what we're gonna do is we're gonna get the alkalinity down, the pH ceiling down, brush this pool, get some SC1000 in here, and start cleaning this up by getting the physics aligned. if you're trying to keep a pool within textbook ranges at the expense of the LSI, water's going to fight you back. Never forget this. Water doesn't care about us. Water doesn't care about the textbook. It never read the textbook. Water cares about getting back to balance. Don't forget that. Any pool pro watching this or any homeowner watching this, you've probably noticed your pH rises. Yeah, it rose because it was out of balance. That's the water trying to tell you something. We got Henry's Law and some aeration from the spillway when it's on. The pH will rise. We got to make sure we contain it with the pH ceiling so that we're LSI balanced, and then we can start cleaning up the pool. If you have any questions, comment on the Facebook post below, and we'll get back to you. I'm Eric Knight with WaterShape. One more at a time. Now, Bill Drakeley has a saying. He says, keep your hands dirty. I'm going to say,